Hi everyone. Today we're going to start to turn our thinking around. So instead of using FOIL to multiply two linear binomials, we're going to have the answer and look to get back to those two linear binomials that we've been foiling. So it's kind of like the backwards problems. Let me explain by starting you out with this slide. What I'd like you to do right now is to pause the video and please FOIL those three problems on the left. Okay, let's see how you did. The x plus 7 times x plus 7, did you get x squared plus 9x plus 14? Our first would be x times x. Our outer would be 2 times x, or 2x. Our inner would be 7 times x, or 7x. And when we combine the outer and the inner, 2x plus 7x will give us 9x, and 7 times 2 is 14. Okay, on the other two, did you get y squared minus 3y minus 18 and a squared minus 9a? And notice the end this time is a positive because the negative times the negative makes a positive. Now, all of these quadratic trinomials are in standard form, and standard form for a quadratic is called ax squared plus bx plus c. So the number that is the coefficient of the square term would be called a, and all of these have the number 1. The number that is the coefficient of the x term would be, we're going to use the letter b, and the constant, very conveniently, would be the letter c. So ax squared plus bx plus c. And today, all of the problems we're going to be working with, the a really won't be, well, it'll be there, it'll be the invisible 1. So what we're going to do today, instead of foiling, is let me put the screen up here. I'm now going to give you these, quote, answers that we were getting and ask you to factor them. So what two linear binomials would FOIL to give you this? So remember that factoring is the undoing of the multiplication process. So we're going to factor quadratic trinomials, or in a few days we will have a special case that's not a trinomial, but we're going to factor trying to get back these two. So instead of being given these two linear binomials and asking you to give me this quadratic trinomial as an answer, I'm going to give you the quadratic trinomial and ask you to give me back these two linear binomials with obviously not seeing them. So let's start this process. Here's sort of the general information. So to factor a quadratic expression means to write it as the product of two linear expressions. We're going to have two linear binomials. To factor means I'm going to give you this and ask you for that. And as we start today, what we're going to start to notice, the foiling process takes those two last numbers, p times q, and that creates the c. So we're going to need this product. We're going to need two numbers that multiply to the number that's out here. Now that's not it. We need a little bit more. Those two numbers are going to have to add. That would be the O and the I in the FOIL. They have to add to give me the B. So we need two numbers that are going to multiply to give us this last number, C, the constant. And those same two numbers have to also add to give us the coefficient of X, which in quadratic language is called B. So let's get an example and see what we're talking about. So see, here I have given you a quadratic trinomial. Its highest degree is 2. It has 3 terms. It's called a quadratic trinomial. The a in this case is 1. At least for today, it's 1. The b is a positive 10, and the c, the constant, is a 16. Now remember what we just said. We need two numbers that multiply to 16. And what I've done is I've written all the possible factors out here, and don't forget your negatives. So 1 times 16, negative 1 times negative 16, negative 4 times negative 4, positive 4 times positive 4, 8 times 2, and negative 8 times negative 2 are the only combination of integers that will multiply to give us 16. So one of these and one of these is going to, this pair is going to kind of take the place here. But now those same two numbers have to add, the O and the I in the FOIL add to give us the b. So if we added 16 and 1, we'd get 17. That's not our b. Same thing with the negatives aren't going to work. A -4 and a -4 is a -8. But if you come over here, you can see that 8 plus 2 is going to give me the 10. So the pair 8 and 2 multiply to 16, but they also add to 10. So this is what I'm thinking is my answer. Now, before we go any further, it does not matter which order you write the two linear binomials. You could have put the x plus 2 in front of the x plus 8. The commutative property of multiplication says it doesn't matter. Now, here's the cool thing about factoring. You can FOIL this to see if you've got the right answer. So x times x is x squared. Outer, I get a 2x. Inner, I get an 8x. 2x plus 8x is going to give me the 10x, and 8 times 2 gives me the 16. So when I FOIL it, I get back the problem I started with it, and I know that this is my answer. Now, funny thing sometimes students do is they'll do this whole process, they'll check it, and then they'll put this right here in the box as if that's the answer, and I kind of chuckle because that's the problem I gave you. So the actual answer is right here. It's the two linear binomials. Okay, let's try another one. So here's another one. Now what has changed is the b this time is negative. I am still looking for two numbers that multiply to 36, and here are all the possible pairs, positive and negatives. Now to get that positive, they either have to both be positive or both be negative. And now these pairs, one of them has to add up to -13. So here you're going to get 37 and -37. Ooh, right here is -13. There's the positive 13. So these are the two numbers that I think are going to be the two numbers in my linear binomials. I think it's going to look like this. And again, the order doesn't matter whether you put the -4, x minus 4 is the first binomial, or the x minus 9. FOIL it, I get x squared minus 4x minus 9x plus 36. And when I combine my like terms, sure enough, I get back what I started, and this is my answer. That is this quadratic trinomial factored. Your turn, guys. Pause the video and see if you can factor these 5 problems, and when you're set, turn it back on and let's see how you did. Now here's the problem with factoring. You can sit there and get frustrated not finding the pair that you need, and the minute I show you the answer, it's like, oh, there it is. So it's really not a strategy I can teach you as much as you need to practice. And the more you practice, your brain kind of gets trained to eliminate sort of the crazy answers and kind of focuses in. So it is a matter of practice, practice, practice. So don't get frustrated. You will get it. I promise. The light will turn on. All right, so how'd you do on the first one? Do you have one of the linear binomials being a plus 3 and the other one being a plus 2? 3 times 2 is 6, and 3 plus 2 is 5. And if you FOIL this, you would get this answer back. How about the next one? 24 is a bit of a bear because there's lots of pairs. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So there are a lot of combinations with numbers like 24, 36, 48, and on and on. So anyway, how'd you do? Did you get the x plus 8 and the x plus 3? And again, the order doesn't matter on those two. This time, notice we have a negative b. So when that happens, notice that our two linear binomials have to also be a minus to get that b to be negative. All of these c's right now are positive. And when they're positive, that means that both of these two linear binomials have to have the same sign. They either have to be both positive or both negative to get a constant, a c that is positive. When are they both plus and both minus? Well, the b tells you if the b is a plus, they're both going to be plus, and if the b is a minus, they're both going to be minus. So the next one, if we take a look at 15, you're thinking 1 and 15, 3 and 5. And then they are both going to be negative because of this guy, right? And there are the two, -5 and -3 will add to give you the -8. Now, when you have two variables, don't freak out. It just means there's going to be a variable at the front and there's going to be a variable at the end. So the x will be at the front of the binomial and the y will be at the end. And then you just have to work with the numbers. So let me just show you what I mean here. So see, the x times x is going to give you the x squared. And notice I put the y here. Y times y gives you the y squared. Now to get a 12, it could be 1 and 12, 2 and 6, or 3 and 4. But to get that 13, and notice it's positive, and that's why these are both plus. To get the 13, it has to be the 1 and 12 combination. So now let's FOIL this one. X times x gives you x squared. X times 12y gives you 12xy. And 1xy in the center. And if you have 12xy's plus 1xy, it'll give you 13xy. And remember that these are all multiplied. So the order xy versus yx, that is the same thing by the commutative property of multiplication. And then finally, y times 12y would give you 12y squared. So what we've just done is factor quadratic trinomials where the c is positive. What happens when the c is negative? So when the c is negative, we're still talking about what numbers can multiply to give us -9. And in this case, it's a -3, a 3 and a -3, a -1 and a 9, a +1 and a -9. Those are really the only combinations, and this one's kind of a repeat, but I just want you to see that we can put in here. And now we need which pair down here, which two numbers add to a +8. And you'll see it's the 9 and the -1. So I am thinking that my two linear binomials, one of them will have x minus 1 and the other one will have x plus 9. So I'm going to FOIL that to check. X times x gives me x squared. Now out here, I've got a +9 times an x, so I have a +9x. And on the inner, I've got a -1x. And a +9 take away 1 will give me 8x in the center. And a -1 times 9 gives me -9. And so sure enough, I got back what I started. So this is the factorization of that. So notice this time, when the c is negative, we're going to have opposite signs. And this guy right here, the b, is going to tell us, his sign is going to tell us which one of these, should be bigger. So I needed the 9, the +9, to be bigger than the -1 to get that +8. So when the c is negative, you're going to have two linear binomials that have different signs. And when the c is positive, you're going to have two linear binomials that have the same sign. And the b kind of helps you know what the sign should be. All right, let's give you a chance to try this. So pause the video and try these. And when you come back, we'll see how you did. Okay, guys, let's take a look at this first one. B plus 8 and B minus 3. Now, if you put B minus 3 in front of B plus 8, that's the same answer. But what is not the same answer is if you put B minus 8 and B plus 3. That would end up giving you a minus 5B, and that would be incorrect. So be careful with your signs. The next one should be m minus 10 and m plus 3. The -10 times the 3 is giving me a -30. And when I look at the outer, I've got a positive 3m, and the inner is a -10m. A positive 3 and a -10 is going to give me that -7m. So what I often do is I'm really looking at what I call the OI, the O and the I, and am I getting the right number, and am I getting the right sign? Our next one should have been W plus 4 and W minus 2. They're opposite operations here because of the negative. And notice the bigger number has to be positive because this is a positive. Okay, down here, did you get x plus 4 and x minus 1? I should tell you right now that often students will have trouble. They'll forget the pair that has the 1 in it. So they'll be looking at the number 24, let's say, and they'll know the 6 and the 4, and they'll look at the 8 and the 3, and they'll look at the 2 and the 12, and they'll forget the 1 and the 24. So just putting that out there as a strategy to not forget that there is also a pair of factors that is that number times 1. Okay, now notice in this case, we know that they have to be opposite signs, but this time the bigger number, which is 12, has to have the minus in front of it to get the b to be minus. So you would have a negative 12x and a positive 1x, and that would give you the negative 11x. So now you look at this one, you're freaking out because there's all these variables. Well, you know, a is going to go at the front of the binomial and b is going to go at the back. And now you just kind of look at the numbers. So we're looking at a negative. So we know that one of them has to be plus and one has to be minus. And the minus has got to hold the bigger number to get this b to be minus. So we need a pair of numbers that are going to add to negative 6 and multiply to negative 16. So again, if you look, there's the a's in the front, there's the b's in the back. Now a times a is a squared. Now the outer is going to be 2 times ab. And the inner is going to be negative 8 AB. And when you add a 2 and a negative 8, that's where the negative 6 is coming from. And then a negative times a positive is a negative, and 8 times 2 is 16, and it's b times b, which is b squared. So today we've learned how to factor quadratic trinomials. We've talked about when the c is negative, they're going to be 1 plus 1 minus. And when the c was positive, they're both going to have the same operation, both adding or both subtracting, and the b will tell you what that's going to be. So where we're going to be heading, just to let you know, is to this type of problem in our next video. So what has changed here? It's looking all the same except for the fact that the a, x squared plus bx plus c, the a is no longer going to just be 1. And that's going to kind of make things a little bit more complicated as we try to figure out our factorization. So guys, I have some practice for you to do, and I need you to understand that with factoring, it is all about practice, practice, practice. And at first, the process will seem possibly slow, and then all of a sudden, you will turn the corner, and like I said, your brain kicks into being able to eliminate sort of the pairs that don't make any sense. So just get started practicing. Don't get frustrated. And remember that the minute you look at the answer, it's like, oh, there it is. There's really not a strategy other than what I've told you today. It's just about practice. Have a great day, everybody.